Okay, let's look at solving exponential equations next. If a to the u equals a to the v, then u is equal to v. The base has to be the same on both sides of the equation. So, if, for example, if we solve 3 to the 3x minus 2 equals 81, let's see, 81 is a power of 3. 3 to the 4th is 81. So, using this rule from above, I can get rid of the bases and set the powers equal. 3x minus 2 equals 4. Add 2 divided by 3, x equals 2. Now there's no reason to check the answer, although you can if you want. 3 times 2 is 6, minus 2 is 4, 3 to the 4th is 81. 3 times 3 times 3 times 3 gives you 81. Okay. Another example. Now with this one, we're going to have to work with both sides of the equation, since 4 is not, or since 32 is not a power of 4. Okay, 2 squared to the 3x minus 1 gives you 4 to the 3x minus 1. To the 5th to the x plus 2 gives you 32 to the x plus 2. Okay, so we got the same base. I'd want to distribute the powers there, the 2 and the 5. So I get 2 to the power 2x minus 2 equals 2 to the power of 5x plus 10. Bases are the same. So 6x minus 2 equals 5x plus 10. Subtract 5x, add 2, x is 12. 12 should be the right answer. Another example, e to the power negative x squared equals e to the x squared times 1 over e cubed. Well, let me work with the right side here for the moment. E to the x squared, the same as e to the 2x, by law 3 of exponents, times e to the negative third power, that's law 5 for exponents. So e to the 2x times e to the negative third gives me e to the 2x minus 3. That's law 1 for exponents. Okay, e to the 2x minus 3 equals e to the negative x squared. Base is the same, the number e, and e meaning the number e. So I can set the powers equal. Negative x squared equals 2x minus 3. I'm going to subtract add x squared to both sides. So x squared plus 2x minus 3 equals 0. Okay, x plus 3 times x minus 1 equals 0. Means that x equals negative 3 and x equals 1. Okay, both those are solutions. Another one, 5 to the power negative 3x plus 9 equals 1. 1 is the same as 5 to the 0 power. Anything to the 0 power is always 1. So I've got the same base there, and the exponents are the same, or would be equal. Negative 3x plus 9 equals 0. If you add 3x and then divide by 3, x is 3. Okay. So there's a little bit with the exponential equations in this section. Probably the bulk of exponential equations is in 5-6, though. Okay. Another thing is compound interest. Is interest earned on principal that is reinvested to earn additional interest. Okay, so it's money that you've made in interest that you're going to let sit there in the bank, and you're going to gain additional interest on the interest. The compound interest formula, A, is equal to P times 1 plus R over N to the NT power. A is the future value of the loan, P is the present value. P is sometimes called the principal. R is the interest rate. The interest rate is usually expressed as a percentage. N is the number of times compounded in a year. And T is the number of years. Sometimes the compounding period is infinitesimally small, in which case we use continuous compound interest. And you can think of that as compounding every second on the second type thing. So when you're compounding every second on the second type thing, to find the future value of the loan, you take the present value times E, the number E, to the RT power. R is the interest rate, T is the time in years. Okay, so let's look at an example here. Part A, find the future value if $10,000 is invested for 9 years at 4.3% rate, compounded. Part A is quarterly, part B is continuously. So part A, quarterly, that means that 4 times in the year we're going to gain additional interest on top of the money that we've already got sitting there in the bank. Okay, so T is, or A is, or P, excuse me, P is $10,000, that's our principal, times 1 plus R over N, N is 4, R expressed as a decimal is 0.043 to the power NT, N is 4, T is 9. 4 times 9 is 36. 1 plus 0.043 divided by 4 gives me 1.01075. Okay, then I would type in 10,000 times 1.01075 to the power 36, and I get $14,695.18. Okay, by the way, you wouldn't want to round this number. Okay, I didn't round that number unless I have to. Okay, if I round too much, that could be pennies off, or in some cases, that could be a couple of dollars off. I don't want to be. I want to write down to the penny. Write down the penny. Okay, so $14,000, $695.18 is what we get. Okay, and problem part B is 10,000. We're compounding continuously. Use the PERT equation to solve. P is $10,000. E is the number E. To the RT power, R is 0.043 times T is 9. 0.043 times 9 gives you 0.387. And so when you type that in, okay, 10,000 times e to the 0.387, I'm getting $14,725.56. Okay, now what that means is that it's compounding every second on the second. Okay, and when you compound continuously, you're always compounding you're always going to find the max amount of dollars at the end. Okay, compared to if you're only compounding 4 times in the year or 12 times in the year, etc. Okay, now I got to be honest, I have never ever seen a bank offer a compounding continuously option. I've never seen that. I've seen compounding monthly several times, and no bank that I know of is going to give you money, $10,000, and invest for 4.3% compounding continuously. I never see that. Okay, now I'm not saying that could happen. So maybe a better example of this could be the population of people in the world. Okay, every second of the day, there's thousands of births that happen all over the world. Okay, we don't have the start-stop thing like you would find. It's not like babies are born at 1 second, and then there's no activity for like 3 months, and then there's, all of a sudden at one split second, there's these, millions of births happening all over the world. We just don't see that. Okay, every second of the day, there's thousands of births happening all over the world. So in a problem like that, if you were going to study the population of the world, it would make the most sense to be using the formula for continuous compound interest, okay, rather than the formula for compound interest. Okay. In fact, the formula for continuous compound interest is used quite often when you study how population grows or gets smaller over time. Usually, it involves the number e. Okay, now not always is that the case, but usually it involves the number e. So it makes sense to be using, a formula that looks very much like the PERT equation there. The next example that I've got here is the population of California, which is in millions, is increasing according to the function p of t equals 37 times e to the power 0.01 t, where t is the number of years since 2010. Estimate the population of California in 2018. Okay. So first of all, the population of this state is continuously growing. Continuously. That's a key word that I'm saying. Continuously. And so it makes sense to be using the formula for continuous compound interest. Okay. So I need to know the population of this state 8 years from now, which is 2010, 2018. T is 8. Okay. 0.01 times 8 is 0.08. 37 times e to the power 0.08. Second e to the power 0.08 times 37 is roughly 40.1 thousand, or million, people. Okay, and that would be estimated population in the year 2018, 40.1 million people. On page 293, problem 112, let's see, where are we at? A model for the number n of people in a community college who have heard a certain rumor is given there, where P is the total population of the community and T and D is the number of days that have elapsed since the rumor began. In a community of 1,000 students, how many have heard the rumor after 3 days? Okay, so n is a function of d. D is the number of days that have elapsed since the rumor began. Okay, how many people have heard it after 3 days? Okay, well, n of 3 gives me 1,000 times 1 minus e to the power negative 0.15 times 3, which gives me approximately 362 people have heard the rumor. Okay. Problem 116. Poisson probability. People enter a line for the Demon roller coaster at the rate of 4 per minute. The following formula from probability can be used to determine the probability that X people arrive within the next minute. So here's P of X, where X factorial is X times X minus 1 times X minus 2 times X minus 3 times all the way down to 3 times 2 times 1. Determine the probability that 5 people will arrive within the next minute, and then determine the probability that 8 people will arrive within the next minute. Okay, so the probability that 5 people arrive within the next minute is is where x is 5. Okay, so I take 4 to the 5th. 4 to the 5th times e to the negative 4th divided by 5, oops, yeah, 5, math, PRB, okay, option 4, 5 factorial, and I'm getting 0.1563. Okay, so P of 8, I do the same thing, but I let x be 8. 4 to the 8th times e to the negative 4th divided by 8 factorial gives me 0.0298 approximately. Okay, and of course as the number increases, the probability is going to go down. Okay, so I've got homework here on 2 pages. On page 331, you find the compound interest and continuous compound interest problems. And on page 290 is all the other problems that I'd like you to look at there. Okay?